Solving exponential equations. There's two types of exponential equations. Some of them require that you use logarithms to solve. Others of them don't. So first we're going to look at the ones that do not require logarithms. An exponential equation is an equation that has your variable that's in the exponent. You can't just use your regular division, multiplication, addition, subtraction to solve this. You're going to have to use some properties of exponents. One of the properties of exponents says if you have two bases that are the same, so in this case we have a base that's 4 equal to a base that's 4, and they both have exponents, then their exponents are just have to be the same. It kind of makes sense. If you have 4 with an exponent equal to 4 with an exponent, then those two exponents have to be the same. So we can essentially ignore the bases and just look at these exponents. So what x would make these exponents the same? If you divide by 2 and cancel that, so you would get x equals 5. So we've solved that particular equation. If your bases are not the same, you want to look for a way to make them the same. So if we have 4 to the 2x equals 64, my base on this side is 4, and on this side is 64. However, 64 can be written as 4 with an exponent. 64 is the same thing as 4 cubed. 4 times 4 times 4 gives you 64. So in this case, we have 4 with an exponent equals to 4 with an exponent. So that means our exponents have to be the same. And then I can just solve for x. I can divide by 2, and I get x equals 3 halves. Alright, if you have more than one base on either side of the equal sign, you need to combine it so that you have a single base. In order to combine this 4 that's a base and this 16 that's a base, they need to have the same base. So again, just like before, you need to write it so that you have the same base. So we have 4 to the 2x, and 16 can be written 4 squared. 4 squared is 16. So now we have a base of 4 with an exponent times a base of 4 with an exponent. And your rules of exponents say that when you have two bases multiplied together, you add their exponents. Alright, so now we have a base with an exponent equal to the same base with an exponent. So that means that our two exponents are equal to each other. Now a little bit of a review whenever you solve this kind of equation. Remember that your variables need to be on the same side of the equal sign. They need to all be combined. So this 2x and this 3x need to be together. So we want to take this 2x off of this side so that it's 0, and then we need to do the same thing on this side. So 3x minus 2x would give us 1x, and that leaves us with 2 on this side. A couple last things to remember. Anything to the 0 power is always 1. So if you have 4 to the 2x equal to 1, you can rewrite that 1 with whatever base you want it to have. So we want it to have a base of 4 so that it matches the other base. Just remember that anything to the 0 power is always 1. And then you can go from there and solve just like you normally would. Another thing to remember is fraction will give you a negative exponent. So 4 squared is 16, which means 4 to the negative 2 is 1 over 16. So you want to write it a plain 4 and just change your exponent to match what's required. So 4 to the negative 2 gives you 1 over 16. So now I have bases that match, so I can solve that equation as well. If it's not possible to find a base that you can change all of your numbers into, then you'll have to use logarithms. And if you have to use logarithms, you're going to get decimals as your answers instead of whole numbers or fractions. They're going to be irrational numbers, decimals that never end. So here's an example of an exponential equation that you have to use logarithms for. There's no way that you can change 17 to a base of 5. 5 to who knows what number gives you 17, and that's where logarithms come in. So we want to rewrite this in log form. So we have log base 5 of 17 equals 3x minus 1. And this is where your calculator will be used. Now your calculator probably does not have a log base 5 button. It probably only has two different logarithm buttons. One says ln, and that's called the natural logarithm, and it is log base e, and e is called the natural number. The other one is just log, and that represents log base 10. It's the common logarithm because 10 is our most common base of things. We use base 10 because we have 10 fingers and we have 10 digits in our numeric system. So the change of base formula says that you can do log 517 in your calculator if you type log of your larger number, the number that's written bigger, divided by log of your base number, your little number down here. So if you type that in your calculator, you should get a decimal that represents log base 517. When you do this, make sure you remember to close your parentheses or your calculator will calculate it wrong. You could also do this with natural log instead of log, as long as you use natural log on both the top and the bottom. Alright, so if we type log 17 divided by log 5 into the calculator, you should get 1.7604. And that'll be equal to 3x minus 1. And then to solve for x, again, you'll add 1 to both sides, and then you'll divide by 3.